So we are doing 7.4. We're talking about area of a triangle right now. And truly, this is some kind of vector stuff, which is stuff that we skipped. But it is okay. We can kind of break it down a little bit and put it in terms of matrices. So that's why that's in here for right now. So what I want to do first is I want to graph this. So I've got 3 little points right here. We're going to go graph these visually on a little coordinate plane. So I'm going to go ahead and draw that out for myself. Going to help us visualize things in a moment. We need to go as high as 7. Okay. 1, 2, 3, 4, 5, 6, 7. So once you got your plane, go ahead and draw your picture on it. I've got 1, -1 is where A is at. 3, 2 is where B is at. And then -1, 7 is where C is at. Right, the reason I like to draw this is because I want to remind you that you can't necessarily use anything that you know about triangles already. So I actually taught geometry last week about the area of a triangle, which I know you probably learned in middle school. At this point, we know area of a triangle equals 1/2 base times height. You guys also did law of sines where we had area of a triangle equals 1/2 AB sine C. What we're going to do now is put it in matrix form. So we are going to use something called directional matrices. So we're going to do something called a directional matrix, which sounds more crazy and confusing than it actually is. We're going to start by picking one point, and I always like to pick the bottom point, the bottommost point, so I'm only going up from there. We're going to decide what essentially, and I'll explain these words in a second, what the vector is from A to B, and then the vector is from A to C. So we're going to do AB and then AC. And so you have to pick one point to always go from. What I have on top of those ABs and ACs is like half of an arrow. So I've got a line and then half of an arrow. That is a vector symbol. And again, that's something that we skipped because of timing. It's least important of all the things that we're doing, but I think it's nice for me to show you that symbol so you can kind of have seen it before. All that a vector is like the distance it takes to get from one point to the other. So we're going to start at point A and we're going to decide what's change in our X and what's change in our Y to get to our new point. So if I go to A, from A to B, I have to go over 2 units, right? I was at the point 1, -1, and I'm going to the point 3, 2. So I'm going from the point 1 to 3. So I'm going to go right 2 units. Are you guys okay with that? And you don't have to label it right 2 units if you don't want to. Now, how far up am I going to go from point A to point B? How many units am I going up? 3. I went from -1 up to 2, so I'm going up 3 units. So my vector for this is going to be 2, 3. I'm going to do my X, my Y. It's just how we go from A to B. We're going to do the same thing with C, A to C. We're going to say, what's our change in X to go from A to C? What's our change in Y to go from A to C? Okay. So our change in X, we were at +1, and then we need to get to -1. So how far over am I going to get from A to C? Left 2. Okay. And then what about my vertical distance? How far up am I going to go from A to C? Up 8. Good. So my vector for this is going to be, how do I represent left 2 versus right 2? -2. -2, 8. And again, you don't necessarily have to choose one point over the other. I just like choosing the bottom point. I think that makes it easier for me to see at least. Okay, now we're going to take this and put this into a matrix, which just means we're gonna combine this into a 2x2 organization. So I'm just gonna combine these two together, and it's gonna be 2, 3 is my top row, and then -2, 8 is my bottom row. That's my directional matrix. From here, in order to do the area, I need the determinant. I'm going to find the determinant of this, and then my area formula, which I know is new here, is going to be 1/2 of the determinant. That's my matrix area. So if we can find the determinant of this directional matrix, we're just going to do 1/2 of that. You guys remind me, how do I find determinant of this 2x2?
It's A minus B.
Good, so I'm gonna do A times D, so 2 times 8 minus B times C, 3 times -2. 2 times 8 is 16, minus a negative becomes plus, 16 plus 6 is going to be 22. All right, that being said, we have to do our area of it, so we're gonna do 1/2 of 22. And 1/2 of 22 is 11. And we're in kind of our area unit for geometry, so I always do units here. So let me make that a little bit bigger so I can write units squared. I'm not as worried about units for you guys, but it's just nice to get in that practice. All right, there's only one like this on here. There will probably be one like this on your test at the end of the week, so I'll make sure to put 1 or 2 on your review that look like this. But does anyone have any questions? I think the weirdest thing is we just haven't done vectors, so the fact that I'm kind of introducing vectors in order to get to my matrix, I think that's kind of the weirdest thing. Okay, we're gonna skip number 2 for right now. We're gonna go to number 3 because I think you'll find number 3 is a review. Number 3 is a review. Number 3 is talking about graphing our rational functions, which we did a long time ago. Graphing rational functions. We did this at least once or twice in quarter 1, or in sorry, not quarter 1. In maybe it was quarter 1, semester 1 in some capacity. I don't remember when everything was, but we graphed rational functions. Remember that we need to graph the vertical and horizontal asymptote and the x and the y intercepts. The last 5th thing that I like to worry about, but doesn't always happen, is the holes. So I'm going to kind of label a little chart over off to the side so that I can remember to find all of those things. And then I'm going to need your help reminding me how we do that. So we're going to do VA, HA, x-intercept, y-intercept, and then we're going to ask ourselves, are there any holes? Does this ring any bells to you guys? Before I start caring about these asymptotes and intercepts, before I start caring about those, I want to factor my function first. So if I factor x squared minus 4, what does that become?
Plus 2x minus 20.
Good. What does the denominator become?
X plus 3x minus 3.
Can I cancel anything out here?
No.
No. So that's the best answer I've got. So we're going to keep this as our kind of base for a lot of other things. All right, so now we're going to use that to find our VA, X and Y intercept and if there are any holes. One of these has to deal with the fact that we have canceled terms. Which one of those would we use if we like canceled anything out? Yeah, Ava, the hole. So do I have any holes here? No. So I'm going to say nope or none, or you can even just cross it out and pretend like it doesn't exist. It doesn't matter to me. Okay. Now, what about vertical asymptotes? What do you guys remember about vertical asymptotes? What do we look at for that? Ava?
You look at the
Denominator. So we're going to set the denominator equal to 0. And I actually might make note of that if it's been a while since I've thought about these rational functions. So I'm going to set the denominator equal to 0. When I do that, if I set x minus 3 equal to 0 and x plus 3 equal to 0, what are my answers here?
It's gonna equal to your negative, it's not what the lines of the cross of the accident.
But we cannot have the denominator equal 0, and so that means my asymptotes are 3 and negative 3. So we're gonna say x equals 3 and x equals negative 3 are our actual asymptotes. Okay. What about horizontal asymptote? Thoughts on that? Ryan? It's a power, so we're kind of looking at like our first terms. If they have the same power, what does that mean? It's gonna be 1. You're looking at the leading coefficient then. So if the powers are the same, then you just go look at the leading coefficients and you make a fraction of that. So I'm gonna say y equals 1. I always have a hard time writing a rule for my horizontal asymptote. So if you think of something cute and quippy, go ahead and write that, but that's as good as I can think of. All right, so we've done denominator, we've done leading coefficients. What about my x-intercept? What's that gonna be? What do I do to find my x-intercept? Exactly, Ella, we said the numerator equal to 0. So the numerator equaling 0 would mean x has to equal 2 and negative 2. And so my x-intercepts are those places, x equals 2 and x equals negative 2. So we set the numerator equal to 0. Last but not least, what about my y-intercept? What's that gonna do? How do we find that? Put zeros in for our x's. And I actually, just like the horizontal asymptote, I like to go back to the beginning and I just like cross off all my x's. I pretend like they don't exist. And so once all my x's are gone, I've got negative 4 over negative 9, which means my y-intercept is gonna be y equals 4 over 9. Okay. Now we're gonna go graph all of these pieces. I like to do my asymptotes first, then my intercepts, and then I kind of connect my dots from there. So go ahead and find a time to do that right now. Make sure your x and y intercepts are in the right place too. And then you should get something kind of like I have, where I've got 3 points in that bottom middle part that's made by all of my asymptotes. When we have 2 vertical asymptotes, we end up getting a parabola of some shape in the middle. So I've got a parabola in the bottom middle kind of quadrant of my graph. And then remember that even though I don't have points in other parts, I know that there are points. I know that it's gonna be kind of catty corner or opposite of where we're at. So if we have our parabola in the bottom middle, then the 2 top left and right, you're gonna have essentially like a crescent or a C curve of some kind, and we're gonna have some points up there. You guys doing okay with that? Do you remember enough to maybe do letter B without me? Or at least start letter B? Go ahead and start letter B without me. for doing my factoring if you wanna check in with me at any point. I think I have all my asymptotes and intercepts put on the board correctly, so go ahead and try those. Get a second. No. Once you believe you have those, go ahead and graph them. Does anyone have any questions or did I do anything wrong? Yeah, Megan,
How do you find? the line?
great question. This Y on the whole, and I'm gonna be honest, I can't remember if we did this a lot, but I know you maybe have seen it in the past, or I know other teachers have done this. Once you get this, the X value, you go and plug that X value into the simplified version of the fraction. The only reason I like to do that is it helps me keep everything in order. It helps me just have a good idea of what's going on. Anybody else questions on that? Okay, I'm gonna work on graphing now. I've got my 3 points, so I'm gonna make my C curve down here in like the bottom. Right, or bottom left quadrant, I'm sorry. And then I don't have any points up in the top right, but I know that's where I'm gonna have my other C or crescent curve, so I'm gonna go ahead and put that up there when you get it. Put that up there when I get it. All right, anybody questions on that one? If you think you've got that one, go ahead and try the letter C. And try letter C. Let's. Looking at letter C, I got a lot of weird fractions on this one, but that's gonna be okay. Double check, make sure that you're right, double check, make sure that I'm right. Once you have those, go ahead and graph them. I don't know how many of you guys are watching my videos later, which you don't have to, I'm not saying this to be weird. But my Zoom like keeps cutting out like halfway through every class, so I just fixed my volume. It acted like I was muted, so if you go through and watch a video and you're like, you're muted the second half or something's messed up, just give me a heads up, because I don't go back and watch them, so. Just something to be aware of. I didn't realize that, so hopefully it's fixed now on this video at least. All right, we doing okay? Okay, I want to flip back to number 2. The more we do on this problem, the less we have to do after the quiz tomorrow. We can get as much of 2A done, that would be awesome. But this is called partial fraction decomposition. So we're just going to do a little bit with this. I've got 2 problems. I believe you do something similar to this in algebra 2, but I like to break this apart with a matrix concept. So it's going to look a little foreign for a while. But I promise we'll kind of get to a point that makes a little bit more sense. That being said, let's start with the steps that we're going to take, okay? So I like to break down what steps we're going to take, and then we'll walk through it in a smaller version, and then we'll do a bigger one tomorrow after the quiz. The first thing we're going to do is factor the denominator, so we can see what my the possible ways that I can split it are. And then the second thing we're going to do is separate or split the fraction. The whole goal is for us to figure out what my new numerators are. And so once we separate the fraction, we're going to have essentially 2 variables in the numerator for us to figure out. And so step 3 is going to be to clear the denominator so that we can solve for those new variables. Step 4, we're going to get to combining like terms. And then we'll end with 2 new equations that we're going to solve using matrices. So it's kind of a weird process, so I like to explain what our thought processes, what our goals are in order for us to get there, okay? So first things first, let's factor the denominator. What does the denominator become when we factor it? Good, x minus 5, x plus 3. And so now when we set this up, we're going to separate this fraction into 2 other fractions. One denominator is going to be x minus 5, one's going to be x plus 3. I do like to rewrite my original one though. It's important to know what this is equal to. We can't just take it like independent off on its own. It's going to be equal to, the variable I'm using is a sub 1, a with a little 1 underneath it. And we'll say x plus 3 in the denominator. plus a of 2 and x minus 5. So far, we factored, and then now we've separated the fraction. We just don't know what my A1 is gonna be and what my A2 is gonna be. That's what we're about to solve. Is everybody okay with what's going on so far? Okay, now we're gonna clear the denominator. So we're gonna multiply by the denominator, which is gonna be x plus 3x minus 5. We did this back in, I think it was chapter 2, maybe, I can't remember at this point. But we've cleared denominators of these big fractions before. When we multiply it by the first term, both of the factors are in the denominator, so everything cancels and we're just left with 5x minus 1. When we multiply it by the second fraction, the x plus 3's go away, but I still have my x minus 5. I'm gonna say A1 times x minus 5. And then the last one, I'm gonna multiply by my last fraction, where the x minus 5's go away, but I'm gonna have A2 times x plus 3. Okay. This was us clearing the denominator. Now we need to get like terms, and I know it's gonna be a little bit messy. We're gonna distribute the A1 and the A2 inside, and then we're gonna combine any like terms that we have. So I'm gonna multiply A1 times x and A1 times -5, and A2 times x and A2 times 3. So my left side stays the same, 5x minus 1, and my right side becomes A1x minus 5 times A1, and then plus A2x plus 3 times A2. Let's see, we distributed, now we're gonna combine like terms. The like terms are the ones that are constants and the ones that both have variables. This has a variable of an x, and so does this. Technically, the only way that I can combine that is by saying A1 plus A2 with parentheses around it times x. I can't combine A1 and A2 and get a smaller or a single number because we don't know what A1 and A2 are. So we're going to combine it like that. And actually for my my constants, my number without x's, -5a1 plus 3a2, we're just gonna leave those next to each other like that. So we're gonna just say -5a1 plus 3a2. Now they are both constants though, so they're gonna be treated together. And then the variables are both came with x, so they're gonna be treated together. Now, this is the part where we need to make this into two equations, okay? I have a variable on the left side. I've got 5x on the left, and I've got a variable on the right. I've got A1 plus A2 times x on the right. Those have to equal each other because they're both going to be like terms. The only way for A1 plus A2 to work is if it adds up to 5, because that's what the left side equals. So we're gonna write that as a new equation off to the side. 5x equals A1 plus A2 times x. And you know what, actually, we can just cancel out that x. We don't really need that x there because the x doesn't matter. It's the same on both sides. Essentially, you can think about dividing out that x off of both sides. Or the like sleep is distracting me. Same thing for the constant. -1 is going to equal these two things combined. So whatever A1 and A2 is, -5 times A1 plus 3 times A2 is going to have to equal -1. So I'm going to write my constants as their own equation over here. Okay. Now we've got these two equations, and I'm going to do a matrix. I would prefer to solve this in inverse matrix, but I think you can do this in RREF, which I'll prove right now. So if we were to do inverse method, we would have to do a to the negative first power times b. Remember that the A matrix always comes from my coefficients on the right, on these side with both my variables, okay? So my A matrix is going to be 1, 1, -5, 3. So I came from my coefficients, 1, 1, -5, 3. And then I'm gonna do the inverse of that and then times it by my B matrix. My B matrix is just what's on the, but the constant that's by itself, it's gonna be 5 times -1. Okay, we're gonna solve that and get a 2 by 1 matrix from that. Now, I haven't done this, so I'm gonna do it in a second and prove it, but I also believe that you could do it, not just inverse method, I believe you could do RREF using an augmented matrix. The only problem is that I know 5 and -1 are like physically written first, but they are the answers, they're solutions, they have to go to the back. So if I were to do RREF, I would do 1, 1, 5, -5, 3, -1. I believe doing both methods will give me the same answer. Okay, so let me prove it to you. I'm gonna do the inverse one first. I need to go change my matrix A to be this new matrix A and my matrix B to be 5, -1. And then I'll do A to the negative first times B. If you're feeling ballsy and you want to try the RREF and see if you get the same answer as me right now, feel free to do so. They both are ways to solve matrices, so they should both work. So I'm gonna go edit matrix A, make it a 2 by 2. 1, 1, -5, 3. I'm gonna go edit matrix B. Make it a 2 by 1, 5, -1. A to the negative first. Times B. And I get the answer 2, 3. And I'm gonna argue if I did my RREF, it would get the same thing. So I'm gonna go edit that. I'll go put it in matrix 3 or matrix C, just so I have two things ready to go. And if I go to math and go RREF, and then do that of matrix C, that's where mine is. Oh shoot, why are they not the same? All right, it looks like I gotta figure out why those are not the same. I will tell you the answer is 2, 3. That's what I have from last year. So I'm not sure why it won't work this way, but I will figure that out for you. Oh, well, let me make that a -5 and see if I get the right answer. There we go. Okay. Ooh, I was sweating over here for a second. So it does work either way. That was my fault. Do you see how silly that was? I missed a negative and my whole answer was wrong. So that's just a little words of wisdom I would give to you. Okay, we haven't done letter B. That's the last thing we need to finish in our notes tomorrow after we take our quiz. Your only homework is to prepare for a quiz. I will make sure that your 7, 3, 7, 4 homeworks are back to you so you can look at those tomorrow. Yeah, Ryan. Say one more time. On my actual notes right here?
Yeah.
Yeah. Yep. All right, I will pause this.